Hello everyone, welcome back to our channel. In this series of video, we are going to see about the important question for examination CO and ARM microcontroller 21EZ52 for module 2. Come, let's go into the video. So the most important question for module 2, analyze how data is written into ROM, discuss different types of read-only memories. So the different types of read-only memory is nothing but the PROM, EPROM, EEPROM and flash memory. So under flash memory, you have flashcards and flash drives. Yes, so moving on to analyze how data, you have to explain all these in detail and analyze how data is written into ROM. You have to draw this diagram where here it at logic 0 the transistor will be connected to the ground point. Yes, so at logic 0 this transistor will be connected to the ground point and the transistor switch will be closed and the voltage on the bit line nearly it will drop to 0. So if suppose if it is logic 1, what happens? The transistor switch is open and the bit line remains to the high voltage. So drawing this is the key points you have to write, and different types of non-volatile memories, that is read-only memories. These are the different types you have to explain in detail. Moving on to the next question. Analyze the work mechanism of asynchronous RAMs. So generally, in order to store the information in the cell, the transistor will be switched on. Yes, so the appropriate, only if it is switched on, the appropriate voltage will be applied to the bit line which charges the capacitor, and after the transistor is turned off, the capacitor will start discharging. So that is why we get this data slave ready, master ready, and this is the timing diagram, that is the bus cycle. So you have two control lines, that is your master ready and the slave ready, where master ready will be indicating that the master, that is the master is ready for transacting the data, and the slave ready is nothing but it is indicating that the slave is ready to transact the data. So here if suppose the MR signal will be 1, then it causes all the devices on the bus to decode the address. Yes, so you can measure at T0 what happens, T1 what happens. So at T0 the master will be placing the address and the commands information on the bus. So what happens at T1? T1 the master is setting this MR signal to 1, so to inform that the, or to inform all the devices that the address and command info is ready and it has been transmitted. So now you have to again start with T2. T2 it goes for the slave performance, where it performs the required input operation and then it will set the SR signal to 1 to inform the device that it has been ready. Yes, so that is how it works. So this is the bus cycle and you have to explain this bus cycle with these two control lines. Next question, elaborate different mapping function used in cache memory. So this is the memory mapping function, that is primary memory, secondary memory, that is mapped to the cache memory connected to the central processing unit. So here cache memory, primary memory and secondary memory. What is secondary memory? What is primary memory? Why it is being connected to the cache memory? What is CPU? All those you have to explain in detail, like how it is differently mapped using cache memory. Next question, write control sequencing for executing the instruction add R4, R5 and R6. So I'll just give you the steps how it should be done. So here you can see that PC out, that is the program counter is out, where register is mapped to some other register B, and MAR in, you know what is MAR in, and read, you are incrementing the, after reading that you are going to increment the PC, that is pointing out to the next program counter. Then you have to again MDR out you have to give, then you have to map it to the next register, then again you have to map, so each and every register, that is add R4, R5, R6 values will be mapped to the different register, and a process of end will be done. So here in a better format to understand, here I've given step 1, where it is the content of the program counter that will be passed through the ALU, that is arithmetic logic unit, using R is equal to B control signal. That is, this is the control signal and it will be loaded into MAR to start the reading process. And step 2 is nothing but the processor will be once it has started reading, right? So the processor will be waiting for MFC signal from the memory to so that it can be mapped. And step 3 is the processor, after getting the data, it will be loading, or loading request will be sent to MDR, and then it transfers them to the IR. Then finally the fourth step is the instruction will be decoded and add operation will be done, and it will be stored in the required registers as said in the, or as you have written your program. Yes, hope you have understood the control sequence and small tips to clear your exam. Please be stay tuned for more information. Thank you.